Logan is our pretend farmer. Logan, what animals do you have on your farm? Cows. Great. Logan has cows on his farm. So Logan is going to make a pen out of 480 yards of fencing. That's what you got. And you're going to be dividing that pen into 3 sections that are all equal in size in area. So he's got his pen, and then he divides it there and there. Why would you want to divide up the sections of a pen? Yeah, different types of cows. You're going to keep some away from the others. Okay, maybe they don't get along. Maybe you have males and females, and you don't want them coming together and making other cows and stuff like that, right? Okay, there we go. So, yeah, so this is the big question: is what dimension should he make the pen to maximize the area? Where do you even start, right? Well, this is where you start, and this is why I love the 4-box approach. You start by drawing a picture. You like the picture? You won't put any labels on here? How about width and length? Now, I don't really know what else to do, but I'm assuming that there's a formula that's involved in this problem. Anybody got a formula? Area, base times height, or length times width. That's pretty cool. Well, here's the problem, is that we know that in order to maximize this area, we need an equation for area, which we have, but we need 1 variable. And right now we have 2 variables. So we need a second equation. What piece of information have we not used yet? My guess is that's going to have an important role. Any thoughts? Okay, Carissa is 90% correct. She says 2W plus 2L is 480. I do have 2 L's, but I don't have 2 W's. How many do I have? I have 4. See that? 2W plus 2. Oh, I'm sorry. I just did it. Krista, you made me make a mistake. 4W plus 2L is equal to 480. Now, that's the part. I can't tell you how to come up with that every time. At some point, your brain has to take over, and you got to come up with that on your own. I'm going to solve for L. 2L is 480 minus 4W. I'll divide by 2. And I get L is equal to 240 minus 2W. So what now? What do you think I do with that? Plug it in where? Yeah, we're going to take this, which is L, and plug it in right there. So now the L variable goes away. What's the only variable left? So therefore, my equation or my function is the area in terms of W is equal to 240 minus 2W times W. And some people get really mad at the left side. They're like, why do you put that W there? Why not just A? Well, this is the name of the function. The function is an area function, and it tells us the area if you know the width. We multiply it out. We get A of W is equal to 240W minus 2W squared. Now we just got to solve the problem. You're still confused because you haven't seen how this works out yet. What's our goal? What are we trying to do? What's the whole objective? What's the problem asking for? Yeah, we want to maximize this area. Well, what shape does this make? student we just talked about the past 2 days? Starts with P, rhymes with arabola. Parabola. Is it right side up or upside down? This is an upside down parabola. What do you notice? Does that parabola have a maximum or a minimum? It has a maximum, and we are trying to maximize the area. That spot on the parabola tells us about the maximum area. In fact, you're used to coming up with an x value and a y value. In this situation, we don't have x and y. We have w, and we have a of w. So our y value is the area. Our x value is the width. Now, what do we call that spot on a parabola? The vertex. Wouldn't it be nice if we had a handy-dandy formula to be able to find the vertex? It would. Shoot. Guess we wait around until somebody invents that. What is it? Negative b divided by 2a. Wow, nice job. All right, we can use that. Negative b would be negative 240. Divided by 2a, or negative 4. And that gives us 60. What the heck does 60 represent? The width. 60 represents the width. The question is, what dimensions? Well, it's going to be 60 yards by, what do I need to figure out now? The length. Is there anything up here that tells me what the length is? Is there something up there that says L equals? Yeah, L equals 240 minus 2W. So 240 minus 2 times 60, or 240 minus 120. 120. Those are the dimensions that maximize the area of the pen. Pretty good, huh? I like it. Now here's the question, and this is where you got to think just a little bit harder. If I come up with 60 here, and I were to plug that back into here, it would not produce the length. What would it produce? The area. It would tell me the area. It would actually give me 7,200, which is what 60 times 120 is. Okay? So that's an introduction. Okay? Now, I know that from my experience, you guys will all be able to do that part. Okay? And you guys will all be able to do this part. And you'll all be able to do this part. It's this box right here that sometimes causes us frustration. Okay? And I'll tell you right now that as you work through this, something has to happen in your brain. Okay? Happened in Chris's brain. She thought of perimeter, and that was really great. Thanks, JB. All right, so let's focus on box number 2. This is where the aha moment happens. We are going to practice those pieces. We're going to do 4 examples. It says the sum of 2 numbers is 24. Find a function that models their product. Product means what? Multiply. So product equals, well, let's start here. 2 numbers summed to 24. What's an expression that would model 2 numbers summing to 24? X plus Y is 24. Good. I want to write an expression for the product of those 2 numbers. So the product would be X times Y. It says to model a function where one of the numbers is X. So I don't want X and Y. I just want X. So somehow you have to see how to get rid of the Y and put an X in its place. Y is equal to 24 minus X. Take that, plug it in right there. So what's our new variable? Are we going to have an equation with X's, or are we going to have an equation with Y's? Which one is it? X's. So the product in terms of X is X times 24 minus X. Got it? A picture is 8 inches longer than it is wide. Find a function that models the area of the picture. That's our goal in terms of its width. I have a picture. I have width. I have length. So how would I write an expression for the area? Area is length times width. Somebody give me something else so that I can get rid of the L and have a W in its place. Length equals width plus 8. Because it says 8 inches longer than it is wide. I take that and I put it in place of the L. And I get area in terms of width is W plus 8 times W. Now we're going to switch it. We're going to give you the area. A rectangle has an area of 40. So that means width times length is equal to 40. But we want to find a function that models its perimeter. So that's the equation we want. What's the equation for perimeter? 2W plus 2L. Any thoughts on how I get rid of L or W? Got to come up with a second equation. I spoke the equation. I did not write it down. Forty is W times L. I'm going to solve for one of these. I'm going to divide both sides by L. I get W is 40 over L. Now I could take that and I can plug it in for W. What's the new variable that I have? Is the new variable L or W? L. So the perimeter in terms of L is, let's see, 2 times 40 over L is 80 over L plus 2L. One more. A rectangular box is a square base. If you've never had practice drawing three-dimensional figures, you can just draw one rectangle and then draw another rectangle that's offset inside of that one, and then just connect the vertices. And you get a pretty decent looking three-dimensional figure. What does it say about the base? Square base, so it's x by x. What about the height? 3 more or 3 times? So 3 times x. How do you determine volume? length times width times height. So the volume in terms of x is 3x cubed. There's an infinite number of examples like this where we show you how to find an equation in one variable. But at some point, you got to take that on your own. So let's do two examples together where we see this from beginning to end, okay? We'll pick up with Farmer Andrew. So Farmer Andrew farms next to Farmer Logan, but Farmer Andrew, he is not going to build his fence the same way that Farmer Logan did. Farmer Andrew is going to build his fence and his pen against a barn. That way, he doesn't have to use the fencing against the barn. He thinks he's smarter than Farmer Logan, and they argue back and forth every day. Farmer Logan steals Farmer Andrew's cows, and Farmer Andrew steals Farmer Logan's tractors. If Farmer Andrew has 320 feet of fencing, what dimension should he make the fence to maximize the area? You always need to start here. Always start here. This is what's driving the problem. That's what's going to produce our final equation. That's what's going to produce our final result. Maximizing the area. So, what do you want to write down first? This is where the magic happens. Area equals width times length. Awesome. We know that's not sufficient because there's two variables that need one variable. What else do you want to do? 320. 2W plus L. Because I have two of the widths, one of the lengths. Now what? Yeah, 320 minus 2W is equal to L. Take that 320 minus 2W, plug it right in for L. That is where the magic happens. After that, no big deal. You guys can do the rest of this stuff in your sleep. Got our 4 boxes. We just modeled the problem, and then we went ahead and created some formulas and a relationship. We now have area in terms of what variable? Width is equal to W times 320 minus 2W. Distribute that W through. Area in terms of W is 320W minus 2W squared. Oh, now I need to solve it. My objective is to what? So what shape does this make? Parabola, right side up or upside down? Upside down. Does it have a maximum? Yes. If it didn't, we'd be in trouble. It means we did something wrong. Want to maximize that area? That spot right there has a W value and an A of W value. How do I find that spot? Negative B divided by 2A. Negative B, so I got negative 320. Divided by 2A, negative 4. That produces 80. At this point, I want to look back and see what the question is asking for. The question is asking for the dimensions. I came up with the width being 80. 80 feet by, now what? Yep, plug it back in right here. 320 minus 160, 160 feet. There you got it. One more example for today. We come back to a problem you're familiar with. A box with an open top is to be constructed from, not to form, from a rectangular piece of cardboard with dimensions 10 by 18. So I've got this piece of cardboard. It measures 10 by 18. And I'm going to cut squares from the corners. And we don't know what the size of those squares are. But what we do know is that they measure x by x. Do you guys remember this problem when we first looked at it? And I actually made one of those things in class for us. I folded up the sides. Our goal is to find the largest volume that the box can have. So what's the first formula I should write? Volume equals width times length times height. Sorry, my smartboard went stupid. So we need to find three things: width, length, and height. Anybody want to take a guess at what the length might be of this new box? Is the new length going to be more than 18, less than 18, or exactly 18? How much less than 18 is it going to be? Two of the x's, right? So the length is going to be 18 minus 2x. How about the width? 10 minus 2x. How's about the height? X. When you fold it up, you can see it's going to be x units tall. Remember, you're taking this, that's your new base, and you're going to fold this edge up. 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 And it's going to be x units tall as you make that piece. Excellent. So I've got volume in terms of x is 18 minus 2x times 10 minus 2x times x. Let's multiply that out. Negative 2x times negative 2x times x is the 4x cubed. Uh-oh, now I got to do my inside and my outside. So negative 2x times 10 and negative 2x times 18. So we have negative 20 and a negative 36. Negative 56 multiplied by this x, and we get x squared. And then 18 times 10 is 180 times the x is 180x. Is that a parabola? Nope, because it's x cubed, right? Had a couple students that they want to do negative b over 2a for everything that they saw. And I took a while to try to convince them that doesn't work unless it's a parabola. So you can't do negative b divided by 2a here. It doesn't work. Well, we do know that a cubic generally has a shape that looks something like that. Does that shape have a maximum? Yeah, it does. We have no way to find it unless we know calculus by hand. But we can find it if we use our calculator. Our calculator can do all sorts of things that we struggle with. So if you look at my y equals, I have it typed in 4x cubed minus 56x squared plus 180x. And as I zoom standard, take a glance at it, can you see the entire graph? No. And so this is probably the most difficult part for people as they look at this type of problem is how do you figure out how to see the graph? I'm going to tell you. We have two parts here. This spot is going to happen at x, v of x. That's what we know. What does x represent in the problem? The height, or how much I cut off, correct? What is the biggest square that you could cut off in this situation? You got 18 for this side. What's the biggest square you could cut off? 9 by 9, right? Because if you did 9, that would take away all of 18, right? What if you consider this side, 10? What's the biggest x value you could cut off there? 5. So if my x value for my window is set to 10, should that be sufficient? Yeah, I see both 5 and 9, right? So that should be sufficient. So our x is okay. Let's think about volume, okay? Farmer Logan, okay? How much do you think we actually end up cutting off? You told me it couldn't be more than 5. So how much do you think we end up cutting off? Give me a number. 2. He says we're going to cut off 2. Well, if we cut off 2, that means the height would be 2, right? What would the width be? 6. What would the length be? 14. And if you multiply these together, 2 times 6 is 12. 12 times 14. Let's see, I'm going to take out my handy-dandy calculator and go 12 times 14, and I get 168. So it looks like you're producing volumes of about 168. So if I go to my window and I put my y values to negative 300 and positive 300, I might have a better shot at seeing that 168, right? See how I did that? I just picked a value. You're like, well, how do you know we picked the right one? I just wanted to choose something that would give me a reasonable idea. Am I looking for volumes in the hundreds, the thousands, the 10,000s? What the heck am I looking for? Let's check out our graph now. Hey, can you see the maximum of that graph? Yeah. How do we find the maximum? Second, calculate. 4. I'm to the left right now. Press enter, and now I will move to the right. I'm to the right. Press enter. Enter on guess. It will find that maximum spot. 2.06. 168.13. Now we just have to know what the heck it means. What does 2.06 mean? That's the height, or that's how much I cut off, right? 2.06 by 2.06. What does the 168.13 mean? That's the volume. What is the problem asking for? The dimensions or the volume? Find the largest volume. Largest volume, 168.13. All right, I've got a problem set for you. Between today and tomorrow, there's 12 problems on the list. Between today and tomorrow, you choose 8. You choose any of the 8 you want. I'll hand it out to you.